Homework for section 7.1, question number 1. This first question is a definition. Practically, we need to match each of the following on the left with the definition or description it represents on the right. I like this exercise because it helps you to learn which variable what means. Okay, N is going to be our sample size. In this case, it's going to be F. Okay. S is our sample standard deviation. Where is it? C. X bar is a sample mean. B. Mu is a population mean. Where is it? H. Sigma, population standard deviation, that is E. P, that is population proportion. Where is it? D. Uppercase N is a population size. P hat is sample proportion. C, D. Didn't we use D? Yeah. Sample proportion. It's population. Where is sample? A. Sample proportion. Okay. Let's check. Bingo. Correct. Okay. Moving to next question. By the way, in this question, in this homework, we are going to work with a hypothesis test, and I'll place the link for hypothesis test, the lecture, so you can read and understand. Please read and understand first the lecture before you do homework and test and everything else. All right? So, according to the Federal Trade Commission, a report on consumer fraud and identity theft, 23 of the all complaints in 2007 were identity theft. This year, a certain state kept track of how many of its 1,485 complaints were for identity theft. They want to know if the data provide enough evidence to show that this state had a higher proportion of identity theft than 23%. State the random variable, population parameter, and hypothesis. Okay, the symbol for the random variable involved in this problem is sample proportion. This is a p hat. There we go, because we are talking about proportion, right? Of identity theft. Next, second question, the wording for the random variable in content as follows. So it's going to be percentage of 1,485 randomly selected companies. Okay, let me see. The percentage of 1,000 randomly selected complaints filed with FTC for that state that are for identity theft. This is what means by wording this p hat. Okay. This one I didn't keep it, huh? P hat, it's a proportion, sample proportion. Next, the symbol of parameter involved, that's a proportion for parameter, it's the characteristics of population, so it's going to be P. Remember from here, P is a proportion for population, P hat proportion for sample. And by wording meaning, let me see which one it is. So the percent of 1,485% of all complaints, actually I would say. Am I choosing? Yeah. That is B. The percent of all complaints should be, here it is, of all complaint filed with FTC for that state that are for identity theft. There we go. Because it's representing entire population, right? That's why we are using all complaints. Okay. Now let's build null hypothesis. Hypothesis test. Like again, so you can understand, you need to watch the lecture for hypothesis test. It will be under this video, the link to my video lecture. All right. Our hypothesis test, what is the claim? Claim, it's gonna be, in this case, our claim, here it is, it says, show that one state had a higher proportion of identity theft than 23%. So higher, that is the claim. And because saying higher equal sign is not involved, so therefore we are using alternative. H0 it's null hypothesis, HA is alternative hypothesis. H0 always carry equal sign. Now, alternative doesn't carry equal sign. So it's greater than, it's gonna be P because we are doing proportion, right, for population. And it's gonna be greater than, in this case, and we have 20.23%, which is gonna be 0.23. Okay, in this case, null hypothesis is gonna be equal to the same proportion, 0.23. Please, please, please watch the video for lecture so you can understand. Okay, we have this. Let's submit and check. We want to check before we move. What is this? Symbol for the parameter. Oh, parameter is P. How did it get P hat? Okay. And the wording is the percentage of all complaint. Where is it? Of all complaint. I don't understand. It's slipping from different ones. I chose percentage of all complaints. Okay, let me check. And this one also, the symbol that random variable involved in this problem, this one is P hat. How is it jumping around? And the wording is gonna be the percentage of, the percentage of 1,360 randomly selected complaints filed for that state that are for identity test, this one. Okay, let's check now. Okay, this one, what is this? It's, okay, it shows now equal. It's not equal. We chose greater than. So this is not good what's happening here. And this one is going to be P. Okay, let's check it. All right. Why this one is greater? Okay, well, let's see what it says here. Here it is. They want to know if the data provide enough evidence to show that this state had a lower proportion. Oh, okay. Lower proportion. Did anything change there? We read greater, whatever. So it's less than, lower proportion. Okay, let's check it. All right. So I guess I have to make sure the answer is registered before I move on. Otherwise, all my answers are dancing around. Moving to type 1 error and type 2 error. So when do we get type 1 error? When we reject the something that is true. Okay? And what is the true? That, let me see. Of all companies filed with FTC that states that identity theft is 23% when it's really 23%. That's what it is. Let me fix it. There we go. I fixed it. So the truth is the claim says that identity theft is 23%, and we don't believe, we reject the case that is true. Okay, that generates type 1 error. You need to watch the video for lecture to understand. Type 2 error, the opposite. They are delivering us the false answer, and we believe that that false answer is true. Okay? Which means, in this case, we are saying we are failing, excuse me, where is it? We are failing to reject that percent of all companies filed with FTC for that state that our identity theft is 23% when the percentage is really lower than that, this one, because they said it's lower, right? Here it is. You fix it. Again, type 2 error generates when they are served with false answer and we fail to reject, which means we accept it. In the language of statistics, we don't use the word accept when we are dealing with hypothesis test. We either reject or we fail to reject, which means synonym to accept. Let's check it. There we go. I guess I have to fix every time register the answer so it won't happen again. Okay, question number 3. FDA regulates that the fish, okay, I think it's a same one, but let me do it again. It doesn't matter since the first one we had a lot of trouble, so we will go over again. The FDA regulates that fish that is consumed is allowed to contain at most 1 milligram or kilogram of mercury in Florida. Okay. Bass fish were collected in 57 different lakes to measure the amount of mercury in the fish from each of the 57 lakes. Okay? Do the data provide enough evidence to show that fish in all Florida lakes have a mercury level higher than the allowable amount? State the random variable, population parameter, and hypothesis. The symbol, question A. The symbol for the random variable involved in this problem is, it's gonna be X bar, Y X bar, because this is the mean mercury level in fish, right? Okay, let me see. In 57, oh, here it is, the wording. Okay, mean mercury level in fish of 57 randomly selected Florida lakes. Here it is. Okay, the symbol for the parameter that is involved in this problem, since X bar is representing the sample, mu represent the population. It's going to be our mu. Here it is. Okay, and the wording is going to be the mean mercury level in fish of all Florida, because population is all Florida lakes. 57, it's our sample. We picked 57 lakes. Okay, mercury level, randomly mean mercury level in fish of all Florida lakes. Okay, fixed it. Question C, let's see what we have. Null hypothesis and alternative hypothesis. Let's see what is given in our case. So the FDA regulates that the fish is consumed, is allowed to contain at most meaning it's gonna be maximum, right? At most greater, equal, right? 1 milligram per kilo, right? At most. I would say, did I say greater? No, it's less equal. So equal sign is there. So it's gonna be our mu, because average the level of mercury. It's going to be our mu. We always test the parameter of population, and it's going to be either less equal or equal. Hypothesis test usually test equal, but we could put it less equal also. And null hypothesis, it's going to be the complement, which means the same mu, but this time, since at most less equal, that's mean alternative is gonna be greater than. It's a complement, okay? And it's gonna be 1. 1 milligram here, 1 milligram here, okay? Let's check so far what we have. This is ridiculous. This is ridiculous. I put here X bar, and here I put mu, and here we're from 50 randomly selected lakes. All Florida lakes. This is not working. This is mu, also was mu. Well, something wrong this time, and we are putting X, equal, and this is supposed to be greater. Why is it messing up like this? Now this, okay, this is good. Okay, now we need to identify type 1 error. Let me remind you, type 1 error occurs when we are served with the truth, but we are rejecting. Okay, so let's see, we need to, our type 1 error has to start with rejecting. All of them are rejecting. Rejecting the mean mercury level of fish in fish of all Florida lakes. Mercury level of fish for all Florida lakes is 1 milligram. The mean really is okay, when the mean really 1 milligram. There we go. Here it is. So there, give us the truth, they tell us the truth, but we reject. That's create type 1 error. Let me check it right away while it hasn't slipped away the answer I placed. Now type 2 error, it's when they are telling us not truth, and we are buying that lie, excuse my French. So what is going to be the answer? In this case, we accept the subject that is not true, right? Which means it's going to be fail to reject. Since we don't use the verbiage accept, it's going to be fail to reject. Here it is at the end. Failing to reject that mean mercury level in fish for all Florida lakes is 1 milligram per kilogram when the mean really is higher than that, because they claim is lower, and that is the case, but now they claim that it's higher, alternative case, higher than that. Okay. I'm done. So one more time, please watch the video for lecture. I will place at the bottom of this below this video. Okay. All right, thank you for watching.